Transcription of the child's utterances are key in the beginning of the clinical analysis of what the child is doing, finding out where the child matches the adult, where the child doesn't match the adult, and understanding in what ways the child's pronunciation differs from the adult pronunciation. So we're going to cover just some basic ideas about transcription so that we're on the same page, and then we'll have some additional small files illustrating transcription for several individual languages that are part of the cross-linguistic project. First of all, what is transcription? It's a way to represent a sequence of sounds where each sound is represented with a symbol such as M. Each sound is also a category, and categories of speech sounds, like categories of anything, are in a hierarchy where you focus on different parts and characteristics in order to determine where in the hierarchy something is. Categories in the natural world can be objects and things, such as dogs. They can be substances, such as water, and they can be speech sounds, such as M. And all of these have a certain shared set of characteristics and concepts that you need to think about. Categories group instances of things based on shared characteristics, and some details may be more important than others. There are boundaries between similar categories. So for example, with color, in English we have the category blue and we have the category green. They're very similar to each other, and as you go across the visual spectrum from blue to green, you get greener and greener until suddenly it's actually green, but it's a very bluish green, and then so on. There's a boundary. On one side, people will perceive blue, and one they'll perceive green. But there's individual differences between people exactly where that location is, exactly where the boundary is. So we've all had discussions where someone will look at a color and say, oh, well, that's blue, and someone else will say, no, it's green. They admit that if it's blue, it's a very greenish blue. If it's green, it's a very bluish green. But nevertheless, they perceive a difference, and whether it's blue or green is very real to each person's perception. In addition to that, speakers of different languages can put the boundary between colors like blue and green at slightly different places, kind of systematically shifted between one language and another, and then on top of that, the individual differences. These kinds of things affect phonetic transcription as well, because exactly the same kind of phenomena can occur. When we're talking about categories, we also have to deal with the narrowness versus broadness of a category. The really broad categories are what we call phonemes. They focus on the phonetic differences between sounds that can distinguish one word from another. So for example, in bog versus dog, it's the d versus b that distinguish the two. And we want to transcribe in a way that captures that difference. But there are other differences that are much finer, that aren't used to distinguish one word from another, and if we transcribe broadly, we wind up leaving these details out. So for example, in the English words hum and hub, there is airflow, there's nasal airflow during the of hum because of the following nasal consonant, whereas the of hub has no nasal airflow because the next consonant is oral and has no nasal airflow. In order to pronounce it like a native speaker of English, you have to have nasal airflow in hum and oral airflow in hub. But a native speaker can predict that. So if you leave out that information, nobody gets confused. Everyone knows exactly what's going on. In some cases, when you're deciding which information to leave out, it's not always clear exactly what you're going to do. So for example, the English B varies between several allophones, one of which is truly voiced and one of which is what we call unvoiced. We use this little ring underneath the B. It's never really a truly voiceless consonant like, say, the p of French. But in order to transcribe the English unvoiced sound, we need this diacritic, and many people prefer to leave off diacritics when they're transcribing relatively broadly. And so you have to make a decision as to how you're going to represent this B ring, which is intermediate between a true B and a true P. Many people use the B symbol and then will refer to the B ring as voiced. Others will use the P symbol and then will refer to the B ring as voiceless unaspirated. Using the B ring is more precise. It's in many ways clearer, but native speakers often don't want to do that, and so will use it more broadly. But if you do that, you still need to keep in mind that you're using a fairly broad transcription and you're not capturing exactly what's going on, which is that you've got something which is intermediate between a true B and a true P, as opposed to actually being either one. When transcribing children, it's best to use at least some narrow characteristics. A totally broad thing that captures only the important contrasts in the adult speech will miss certain kinds of things. So for example, you might want to know whether a child nasalizes a vowel before a nasal consonant or not. When you're dealing with aspiration of stops, like the English aspirated p versus the French unaspirated p, you might want to distinguish those two. Sometimes child will use them contrastively, if you want to use that term, where a word like pot will be pat with an aspirated P, but a word like spot will be pat with an unaspirated P, and then the word like bought will be bat with a B ring. And we want to distinguish those kind of things when they occur. So it's best to transcribe narrowly to at least some degree. How narrowly will that be? Well, it depends which language you're doing and what kind of things native speakers feel comfortable doing. For each of the languages in our cross-linguistic study, we have sat down and had a conversation between several native speakers and a phonetician to determine which things they feel comfortable transcribing, which things they feel they could accurately transcribe, and which things they actually want to transcribe. And we've worked out a set of transcription conventions. If someone transcribes more narrowly than the things that must be transcribed, the transcription conventions say basically what won't be paid attention to while you're determining whether two transcribers have transcribed in the same way. But it also says things that we're not expecting to see there. So if at some point we want to study some characteristic which isn't being transcribed because it's viewed as too narrow by the native speakers, we have to go back to the original files and redo it, and most likely do acoustic analysis. We have the transcription conventions for the languages in our project posted elsewhere. If you're working on a language that's not included, you'll have to work out the transcription conventions yourself. We have the criteria for developing such conventions also available elsewhere on our website. There's a hidden assumption behind the symbols that we use for transcription that most people don't really think about. One thing basically is it assumes that every speaker has basically equivalent vocal tract. And for adults, that's quite likely to be the case. But as we deal with children and some special populations, it's not necessarily the case. One exception is where you might have a speaker with a vocal tract which is different enough that it doesn't behave functionally in quite the same way. So for example, children with unrepaired cleft palates. Those vocal tracts are set up in such a way that it's extremely difficult to prevent nasal airflow, and children can wind up producing atypical sounds, in some cases sounds that a typical vocal tract might not be able to produce very easily. When you're dealing with that sort of thing, it's not clear that the IPA is always exactly the right thing to do. This also holds true for children and adults who have atypical auditory systems, such as profound deafness. They may be producing things in a way that aren't really following the categories that typically hearing people would produce. And in that particular case, they'll produce a lot of things which aren't really don't quite match what typical speakers would do, don't really fall into categories very easily, and wind up being extremely difficult to categorize. And in some cases, what a typical adult might hear listening to this speech doesn't correspond to what was intended by the speaker who may have a profound deafness. In that case, the IPA isn't really an appropriate kind of thing. In some cases, what we find is that there are differences in vocal tract shape and the ability to control the tongue that children have that lead us to certain kinds of transcriptions which may be a bit misleading, and certain kinds of sounds which may be difficult that we adults weren't really expecting to come across. First, the issue of vocal tract shape. There's one thing that really stands out, and that's the vowel ah. In adult English, the vowel ah is a fairly back vowel in a pronunciation like dog in those dialects that don't happen to round the vowel and say dog. But the child doesn't quite match that vowel. Children most likely at a very young age, say under age 5, will often say something more like da. And that's a much fronter vowel, and we use the IPA symbol, which is just a regular printed A, to describe that sound. If you look at the IPA chart, you'll see that this sound is actually classed as a very low front vowel, whereas the adults are producing a back vowel. But as we look at co-occurrences between vowels and consonants in the child's speech, we have to say that this doesn't really seem to act like it's a front vowel. It seems to act more like it's a back vowel. And the conclusion that we've drawn is that there are differences in the shape of the vocal tract for children versus adult, which usually lead to acoustics which match fairly closely. But in this one particular case, we're getting acoustics which are a bit misleading. And the child is probably actually producing a very low central vowel as opposed to a front vowel. But as an adult, to match the acoustics, we would have to use a very low front vowel to match it. So even though we might use this particular symbol as a printed A, it's probably much more of a central vowel, and you should bear that in mind for some purposes. The other thing we want to draw attention to is that the certain sounds in adult speech require the tongue to be deformed in fairly serious ways. And the child's tongue might not be flexible enough. It might not be deformable in quite the same way. Where does this come up especially? Well, it relates to anterior coronal sounds like T, D, N, S, and Z. The tongue tip is at the teeth, or actually at the alveolar ridge in adult speech, but often more at the teeth in child speech. In adults, we keep the main body of the tongue fairly low. And there's a reason for that. We have to keep that main body of the tongue out of the way so it doesn't get in the way of the airflow and alter the acoustics. So when we're producing T, D, N, S, and Z, it's pretty much concentrated right at the tip of the tongue or blade of the tongue and the alveolar ridge. That's where the noise is produced. Children are unable often to lower their tongue out of the way. The tongue body remains relatively high, and it's high enough that it actually significantly changes the acoustics. The IPA refers to such sounds as alveolopalatals, and they're viewed as having a complex place of articulation. So they're not on the main charts, but they're in the set of other symbols. The tip of the tongue, as children produce them, will be at the teeth, but there'll also be frication produced not just at the teeth and alveolar ridge, but even more posterior into the area that is much more associated with palatoalveolar sounds like the sh and zh of adult English. And they sound a little bit like sh and zh because of the characteristic frication along that big long axis. But for a sh and a zh, the tip of the tongue is retracted. So it's behind the alveolar ridge, between the alveolar ridge and the hard palate. Whereas in a alveolopalatal, which is this little C hook and Z hook, the tip of the tongue is at the teeth, and you're simply getting frication along a wider area. This is extremely common among children, and we have observed it in all of the languages that are involved in our cross-linguistic study. It's actually relatively uncommon in adults, and the number of languages that have that are relatively small. T and D and N, on the other hand, even though they're also made with a high tongue body, wind up getting less acoustic interference. And so in English, even though T and D might have a high tongue body, adults perceive them as the intended T, D, and N sounds. Greek, however, also has palatal consonants. And what happens there is that on at least some instances with some tokens, adults will perceive palatal stops instead of dental stops, especially if palatal stops are intended in that particular word. So bear this in mind. We don't exactly know how to think of these, but they are certainly dental articulations. So I've alluded several times to the fact that when we're transcribing, we use the International Phonetic Alphabet. This is a standard transcription system in Europe and much of the world, and in North America it has been adopted as the standard in speech-language pathology, but will not necessarily be the standard in works in linguistics or psychology. The IPA was designed originally to capture the phonological contrast, in other words, to be very useful for broad transcriptions. Insofar as narrow details were possible, they were really done to aid in the transcription of contrasts, broad transcriptions in various languages. Through the years, some diacritics have been developed that are only narrow for narrow transcription in some languages, but we don't entirely have a full set of clear diacritics that would absolutely capture all aspects of narrow transcription. In some cases, for example, if you need to denote a bilabial approximant that's not rounded, like a W would be, you actually have to use the symbol for a fricative with another symbol that means, well, the aperture isn't quite, is a little wider than you would get in a fricative. It doesn't clearly mean that you're using an approximant, but it's a way that you're unlikely to be using for other purposes, and so it can be used in that way. Even this isn't enough for everything we observe with children, so there is an extended set of symbols which are basically designed for use by speech-language pathologists. The IPA defines the standard values for sounds, in a sense, the perfect examples of a sound. One thing it does not set is the boundaries between sounds. Those are allowed to vary between speakers of different languages and between individuals. As a result, when there's a beautiful, clear, central token of a given sound, there tends to be a lot of agreement on it. But when it approaches a boundary that a transcriber has, we wind up getting a whole lot of variation across individuals. It's often the case that someone will say, well, no, it is a T. It's not a very good T, but it's a T. And someone else will say that it's a different sound. So that must be borne in mind. This is one of the big sources for differences across transcribers. The next couple of slides here just basically remind you about what we're doing. Everyone has seen this sort of thing. Here we have the vocal tract labeled with the different places of articulation on the top there, the different articulators on the bottom, the larynx or glottis down here at the end, nasal cavity, and so on. This is the International Phonetic Alphabet, organized by place of articulation at the heads of all the columns, and by manner of articulation as you go down at the heads of all the rows. And then within each cell, there's a distinction between voiceless and voiced. There are also diacritics and vowel symbols, which are available. And this is the extended IPA used for disordered speech. You can't possibly absorb all that from this. So what you need to do, if you haven't actually got these available, is to go onto the web, go to websites where you can download the charts. And if if you go to the ones we have right here, you'll be able to get the regular IPA either as one full chart or actually broken down by various functional subsets, and the extended IPA for use by speech-language pathology. You can also find these charts plus other things on various websites around on the web. A very recent thing that's available is an app for the IPA for iOS operating systems, such as you would find for iPads and iPhones. Unfortunately, not available for desktop computers, not available for laptop computers, not available for Android systems. It's a beautiful application. In addition to the IPA charts, if you click on the sounds, you can hear and listen to the sounds, and in many cases also get articulatory imaging from ultrasound or other sorts of ways of actually observing what the articulation is. And you can, in some cases, have a recording of a child right in front of you and ask yourself, I think that's an epiglottal trill. But it would be nice to listen to an epiglottal trill to actually be able to compare. And whew, there you have, you can listen to the epiglottal trill and say, yes, that's exactly what I just heard. This is not made up. We were transcribing an Icelandic a child who was using an epiglottal trill in place of an alveolar trill, and to be able to confirm instantly like that was incredibly useful. Not quite as useful, but available on more different kinds of systems, are other sorts of things from these websites here, from various places around the world, and we found them to be very useful for reference and for ear training as well. I want to end by talking about a few things that you want to focus on, how things, the different kinds of categories that we deal with, and kind of how difficult they are to produce, and therefore what kinds of things tend to happen in phonological development. First of all, there's manner of articulation, where we have divisions between obstruents and sonorants, and then further divisions within each category. Obstruents are produced with an increase in pressure above the larynx, such that you have to coordinate very carefully in order to be able to get voicing, and voicelessness is much easier. There are three basic kinds of obstruents. There are stops, fricatives, and affricates. Stops have no airflow through the oral cavity or through the nasal cavity. T would be an example. And this sort of thing just basically involves closing off everything. It's very easy to control, very easy to learn, and this manner of articulation tends to be present in babbling and in the earliest words. In fricatives, however, the nasal cavity is closed off, but the oral cavity is not. There's a narrow constriction in the oral cavity. Air goes through that in a way that produces turbulence, a hissing sound. There's continuous airflow through the oral cavity. S and F and th would be examples of that. In order to get turbulence, you have to have precise positioning of the articulators. If the two articulators are too close, you'll basically choke off the airflow and you'll get a stop. If they're too far away, you won't get turbulence and you'll get something more like an approximant. In order to control the tongue and lips in such a way that you get these narrow apertures is actually a fairly fine type of control. It's much more difficult than producing a stop, and as a result, it tends to develop somewhat later in child speech. Affricates are sort of a cross between the two. It's a complex articulation that begins like a stop and ends like a fricative. It also has fairly precise timing and movements, but probably not as precise as fricatives. Basically, you can close off the vocal tract as strongly as you like and then just pull it slightly open. It's still more difficult to control and learn than a stop is, and is also somewhat later in development than stops. Among sonorants, there are a couple of different categories. There are nasal stops that close off all the airflow in the oral cavity and allow airflow through the nasal cavity, such as m and n. And this, again, is extremely easy to control, extremely easy to learn, and the majority of children have this among their earliest words. There are also liquids, and several different types of articulation within liquids. They tend to be relatively unusual or unique within a given language. A minority of languages have two liquids of the same type, for example. And there are several types. One type is a tap, which involves a rapid movement of the tongue tip, kind of like an extremely short stop. And the example from English would be the D of the word muddy. But in many languages, it's thought of as a kind of R, such as in Spanish or in Japanese. It requires a relatively unique kind of timing and control, which is either ballistic or aerodynamic. Very precise positioning of articulators and movement, relatively difficult to control and learn, and it is mastered late in almost all languages. There are additionally trills. They're aerodynamic. They involve an oscillation of the tongue tip or the tongue dorsum, like in r or r. And they are also difficult to control. They are learned relatively late. You have to have things in exactly the right position with exactly the right airflow to get them. And children simply don't have them early on. The last kind of sonorant consonant that's a true consonant is a lateral. It involves absolute closure at the tip or blade of the tongue, but one or both sides of the tongue are lowered. It tends to be relatively unique in most languages. There aren't many different kinds of laterals. It's somewhat more difficult to learn that and control it, so it's a somewhat later development, but actually not that late in languages with relatively simple Ls. In English, we combine a dorsal constriction with the apical constriction, and that added complexity makes it a very difficult sound, and it develops somewhat later. We call that the dark L, which is this symbol right here. There are also vowels and some vowel-like consonants. The vowel-like consonants are called approximants. They have a vowel-like positioning of the articulators. Tongue movements are relatively slow. In most languages, the approximants that we typically see are w and y. They're relatively easy to control and learn, but they're relatively different from the other consonants, and sometimes they'll lag behind the stops and nasals. These are not the only approximants that we get, however. You can have an approximant at virtually any place of articulation, and in Spanish, the consonants which are spelled with a B, D, or a G between vowels are often transcribed with a fricative symbol, the, and the, but frequently have no frication and are much more of an approximant. The IPA does not give us symbols for that, but we have the diacritic that says widened aperture in order to be able to transcribe them if we're transcribing narrowly. There are also glottals, which have no constriction above the larynx. That typically is H and glottal stop, although there's also the breathy voiced H. These are relatively easy to control, relatively easy to learn. Children also get these sounds relatively early. And then there are vowels with a fairly wide open vocal tract, no obstructions of the airflow anywhere, and they're relatively easy to control and learn as well, although the more different vowels a language has, and therefore the more precision that must be made with exactly how wide the aperture is, will lead to some vowels being learned somewhat later than others. We also have to deal with laryngeal categories of consonants and vowels, and there are somewhat fewer different categories there than there are for manner of articulation. Many consonants and vowels are voiced. Voicing involves a rhythmic opening and closing of the vocal folds in the larynx, which requires a constant movement of air through the larynx. And that requires a relatively low pressure above the larynx. And what this means is that if the pressure above the larynx is naturally low, voicing is relatively easy and automatic to do. And this will happen if there are no constrictions in the oral cavity, such as vowels, approximants, or the constriction in the oral cavity doesn't last very long or isn't a full occlusion of the airflow, such as in liquids. And it will also be the case if the nasal cavity is open, as in nasal stops. Voicing is fairly easy, automatic. Children develop it fairly quickly. Voicing becomes more difficult if pressure above the larynx is raised, and this will happen in all obstruents, stops, fricatives, and affricates, especially in stops where all airflow is stopped and the pressure automatically raises. If you're going to stop, if you're going to produce a stop which is voiced, voicing requires a constant flow of air. It then stops above the larynx and the pressure raises to the point where eventually voicing will end. And that makes voiced stops relatively difficult to do. Voiced fricatives are difficult as well, but for a somewhat different way. Fricatives allow the air to constantly escape through the vocal tract, through the oral cavity, and as a result, the pressure never builds up too high. However, in order to produce a fricative, you have to have a narrow enough constriction to produce frication. And in order to get the turbulence, the fricative noise, there has to be a certain amount of pressure behind it. And so it winds up with inherently higher pressure than you would get in a vowel. In order to produce voicing, you have to find a range of pressures, a very narrow range of pressures that are high enough to get frication but low enough to allow airflow to give you voicing. And finding that one narrow range that works is a relatively difficult thing. And as a result, voiced fricatives are much more difficult for children than voiceless fricatives are. Voiceless consonants and vowels occur with a number of different variations. One common one, probably the most common one, is to have the vocal folds spread. And so that will happen, for example, in an H, like it also happens in aspirated stops, like p, t, and k in English, and it also happens in fricatives. This is something that people will often miss. You don't actually have to have a spread glottis when you do a s or a f or a th. However, if you have a spread glottis, it leads to a much higher flow of air, which leads to a much better and louder bit of frication. So you can produce much better s sounds with a spread glottis than without, and virtually all languages have wound up having that spread glottis relative to the fricatives. It's called an enhancement feature. Young children will ultimately need to develop that as well. Some children seem to catch on to it earlier than others, and as a result, fricatives may, for example, be produced as H, they may be produced as aspirated stops, and so on. Some voiceless things have vocal folds which aren't spread, but for various reasons, the conditions aren't right for voicing, such as, for example, too much pressure above the larynx. And what you get there is voiceless unaspirated stops, like in the French p, t, and k, and in many other languages. And lastly, you can constrict the larynx in various ways, such as basically producing a stop there, which is the glottal stop like we have at the beginning of the word apple. And then there's creaky voice. The vocal folds are constricted, but they're also not very tense, and you wind up getting irregular periods, and you get things like ah. And this is used contrastively in some languages. In other languages, it's more of a stylistic thing, or something that happens when you drop pressure a bit too low and can't sustain regular voicing. And you'll find this relatively often in child speech as well. If there's an excessive amount of it, it can be a voice problem and should be considered while you're transcribing. For place of articulation, we make a number of different distinctions depending on which articulators are being used and exactly the shape of that particular articulator. Things which are rounded, for things which are using the lips, are called labial, and there are bilabials. There are things which, like p, b, and m. There are things which are rounded, like u, o, and r. And actually, I've missed one here. There are things with a labiodental articulation, like f, v, or an approximant w. Coronal sounds are made with the front half of the tongue. That can be the tip or blade of the tongue, and it can actually also be closer to the center of the tongue. So you wind up being able, if the tip or blade is touching the teeth, they're dentals. If it's between the teeth, it's an interdental. If it's slightly further back, it's an alveolar. Further back yet, with the positioning of the tongue, is the palatoalveolar. If the tongue tip is relatively low, but the front half of the tongue is still raised, you'll get a palatal sound. And if the tongue is at the teeth with a high tongue body, you'll get an alveopalatal, as we talked about earlier. With a low tongue body, you get dentals and alveolars, and a high tongue body, you'll get these things. All right. Then if you're using the back part of the tongue, those are called dorsals. They can be palatals, so those are both coronal and dorsal. And a y would be like that, or a palatal stop like ka, or nasal like nya. Or you can get velars, which are not coronal, like k, g, and ng, and you can get things further back, uvular, like ka, ga, and so on. The vowels are basically all within this range. All vowels are dorsal. The front vowels are also coronal. They vary perhaps between being velar or uvular as well. Note that there can be two places of articulation. A front vowel is both dorsal and coronal. A rounded vowel is dorsal and labial. And you can have all three combined in something like a front vowel e, or the English r sound, which is rounded and therefore labial. It has a back constriction in the uvular region, so it's dorsal, and it also has a constriction involving the front of the tongue, so it's coronal. Just a few words about transcription. Depending on what you're using this for, you may want to do certain kinds of things. In the clinic, people often transcribe live. That has the drawback that you have to listen to something enough times that you're sure what it is. If it's something you're unsure of at first, like, whew, what is that? Having to deal live can be somewhat more difficult. If you record, you can then listen to it again when you have more time and go, aha, I see what goes on there, and you can get more accurate transcriptions. If you record, you can also use a computer as a playback device, and on the computer you can get a free program that can be downloaded called Pratt. Just search for Pratt in Google, for example, and you can download it. You can get acoustic information at the same time as you're transcribing. And that acoustic information in both waveform and spectrogram can be used to supplement your ear in terms of transcription. And you can sometimes tell what's going on in ways that are a little bit harder to do from the ear. If you use just acoustic analysis like that, it's actually more difficult. Using both the ear and acoustic analysis at the same time can often be extremely rewarding. If you're doing something for more research-oriented purposes, that's definitely a recommended way to go. The only thing you're missing is visual information, and we'll get back to that in a minute. Visual information about the face. So I just want to show you how we can how you can look at certain things that using Pratt with the acoustic analysis. So I have a number of slides here that deal with manner of articulation, contrasting ta, sa, and cha, laryngeal differences such as voiced ba, voiceless ba, and aspirated pa, and place differences such as ba, da, ga in stops, and fa, tha, sa, sha, cha in fricatives. So first, the manner of articulation. So here you have ta, sa, and cha. And what you can see here is a very, very sharp edge. That's relating to the burst. If you look here at the acoustics, you can see kind of a little spike before the vowel kicks in. And no noise, particularly. In sa, you can see some high frequency noise. There's actually far more if you follow it up above 5,000 hertz, which is what I've got illustrated here. And then at the end of that, the vowel starts up relatively abruptly. And that's what you see for stops versus fricatives. And then for the affricate, you notice that, again, there's noise. There's no voicing down here. There's noise. It's much shorter than the frication here. Why is it shorter? Well, because it starts with a stop-like portion, and the frication is going to be roughly half what you'd expect if you had the equivalent fricative. And you can see here that there's a relatively sharp onset, and then you get louder frication, and then you get the vowel kicking in. So there's actually a burst that's visible there as well. Now we're going to look at ba, ba, and pa. So there's ba, and here you can see that there's a little bit of noise down here. That's called a voicing bar. And you can see it here on the waveform as well. I'm afraid, emphasized this fairly strongly. That's not necessarily unusual. Sometimes we see these voicing bars very, very strongly in the child tokens that we look at. If you look at pa, which is an unaspirated P, you'll see that there's the burst and there's no voicing noise right beforehand. And right after the burst, basically the vowel kicks in very quickly. In pa, you see a burst and then you see a noisy area and there's no voicing down below, and then it starts. You can see that here. There's the burst, there's some sort of noise, and then you get the vowel. The noise is not very loud. It's not nearly as loud as a fricative, and that would be how you tell whether something is truly voiced, whether or not it's a voiceless kind of sound, and whether or not it's an aspirated sound. Now we're going to look at place of articulation, first with stops, ba, da, ga, and then with fricatives. So here are the stops, ba, da, ga. Note, by the way, that you can see good voicing bars on all of them. If you look closely here, what you can see is that the first formant and the second formant, and actually the third formant, are all rising in a b. In the d, however, you can get a rise here on the first formant, but you see the second formant dropping, and then the third formant is relatively straight. On my ga here, the first formant is rising, the second formant is falling, but the third formant is rising. And actually you see the two formants here come together. This is called the velar pinch, and it's a characteristic of a true central velar. If I front the velar a little bit, like I would in the word ki or gi, or if I back it a little bit, as sometimes will happen in a word before an ah, and produce something more like ga, that's not quite a uvular, but it's a little bit further back than I produced it here, you will not get that velar pinch. So that's an interesting characteristic. For the fricatives, fa, tha, sa, sha, and cha, you see several things. Sa and sha are very loud, much darker, and the frication is much higher amplitude. And you can see s is relatively high frequency, sh is much lower frequency. Ch is a little bit quieter and is a bit more broad. Actually looks like there's a bit of high frequency and a bit of low frequency. Th and f are very low amplitude. And if we could look at the spectrum, F tends to be a little bit lower, Th tends to be a little higher, but they're easily much more confusable. And you actually have to look for the formant transitions to really see the difference. You can see a rise in this formant here, and this formant is actually more steady. And you can see an almost velar-like pinch here in the sh, a rising formant here and a falling formant there. So you can see that if you weren't quite sure what you were hearing, by looking at the acoustics like this, you can help differentiate things. And it can be quite good for relatively subtle things. Or if you ask, well, is that a vowel, a monophthongal vowel or a diphthong? That kind of thing often will be relatively visible on a spectrogram, much more so than your ear if you're unsure of exactly what's going on. The last thing I want to mention, though, is that while you're transcribing, you should probably be paying attention to visual information. This illustration of visual information actually is something that doesn't help you very much. It's called the McGurk effect. But it illustrates that we're sensitive to visual information. I can't show you the McGurk effect, unfortunately, because that would be, I don't have my own videos to demonstrate that. I would have to use someone else's, and we would rather have you go somewhere and look. So, for example, you can see Pat Kuhl from the University of Washington talking about the McGurk effect at this particular address on YouTube. So if you've never seen it before, go and do that. You can do it with many different things, but the original one that was discovered by Harry McGurk involved combining the visual information of the face with someone saying ga, and the auditory presentation of ba, and what's perceived as da. Ga and da share a certain visual information, which is that the mouth is open, the lips are not closed, but their jaw angle tends to be a bit different. And b and d are a little bit more. And b and d and g share certain auditory information, but given that you're hearing a b and seeing a g, d is a compromise that's kind of a good fit for the visual and kind of a good fit for the auditory. And the very fact that you can get this illusion at all says that we're actually paying attention to visual information and auditory information. Now, in real life, the McGurk effect does not happen. Well, unless it could possibly happen with ventriloquists. So if you deal with ventriloquists, their lips aren't exactly matching what they're doing, and they're hoping that you'll still perceive the speech sounds that they're wanting you to perceive for the individual words. But outside of ventriloquism, the lips and the face match the sounds. They're being produced together. And although you'll get strange things happening if you mix and match between the visual and the auditory, under normal conditions, they reinforce the same thing. So if you happen to see the lips at the same time and jaw at the same time you're transcribing, your transcriptions can be a bit more accurate. If it's a little bit noisy, you're not quite sure whether or not the lips are being used, you can easily see that. You can see whether or not a child is actually rounding an oo or is producing an unrounded oo. You can see the difference between a true labiodental f or v versus a bilabial f or v. They sound a little bit different, but visually they are strikingly different. And children well before the age of 12 months are aware that f and p are made with different lip shapes. So if you can use visual information when you're transcribing, it's a good idea to do that. Especially if you're transcribing live, use that visual information. Okay, that's all that we have to talk about relative to transcriptions. There's a lot of things to pay attention to, perhaps some software to download, and certainly some transcription conventions for individual languages to either download from our site or to develop for other languages that you're working on. But this gives you the basic kind of thing that you need to work on. We have several additional tutorials that will go with this one. One is about how you get from the phonetics to phonological features, but there's also a series of things illustrating transcription using child information from children who have protracted phonological development. We're starting out with just a few languages, and we'll add more as time goes on. So look for those. Hopefully there'll be a language that you're interested in seeing, being talked through a number of transcription issues.